In this and the next episodes, we are going to focus on the evaporation process. In this episode, we will have a quick overlook of evaporation, and in the next one, we will go into the details of the process. So evaporation is a process by which molecules escape from the liquid to the gas state. For a liquid to evaporate, its molecules must gain enough kinetic energy to overcome the attractive force among them. Remember, at the beginning of this chapter, we introduced the kinetic molecular theory. Okay, all those molecules within the liquid, the reason they're staying together is because they have a potential energy that is trying to keep everything in order, that is attracting all the molecules, making sure they are staying together. However, molecules also have another form of energy, which is called kinetic energy. Now, in the liquid state, kinetic energy and potential energy are comparable. As a result, molecules cannot move away from each other. They have some freedom, but they cannot go into gas state. Molecules in gas states are totally free, totally independent. These molecules want to be free, however, they cannot because they are controlled by their potential energy. For the molecules that can go from liquid to the gas state, those molecules must have enough kinetic energy so that they can overcome the attractive force, which is the potential energy. Now let's talk about the factors that affect the rate of evaporation. First of all, it's understandable that only the molecules on the surface of a liquid can get evaporated. Molecules within the body of a liquid, on their way out, they will bump into many other molecules. They cannot get evaporated. So as a result, greater surface area, faster evaporation. Another factor that affects the rate of evaporation is temperature. On the last slide, we learned that for molecules to get evaporated, they need to gain enough kinetic energy to overcome the potential energy or the attractive force. How can molecules gain higher kinetic energy? Higher temperature. We learned that at the beginning of this chapter when we first introduced the kinetic molecular theory. The higher the temperature, the greater the kinetic energy. As a result, when you raise the temperature of a liquid, more molecules will have enough kinetic energy to overcome the potential energy or the attractive force to get evaporated. So the higher the temperature, the faster the evaporation. Let's think about this evaporation. Let's say that you have a drop of water on your skin. When they evaporate, how do you feel about that? You feel that it's getting cooler on your skin, right? Why is that? Well, because for the water molecules to get evaporated, those molecules are at a higher energy level. They have higher kinetic energy. So the molecules have higher kinetic energy evaporates first. The leftover molecules have relatively lower kinetic energy, which means they are at a lower temperature. That's why a cooling effect is produced in the liquid when evaporation occurs. Well, we keep talking about evaporation. Now let's use water as example again. For water to go from liquid to gas, usually at 1 atmospheric pressure, usually it happens at 100 degrees Celsius. It happens at the boiling point, correct? So normally water will become a gas under 1 atm at 100 degrees Celsius or above. Below that, water will be considered as a liquid. However, even if the temperature is lower than 100 degrees Celsius, we know evaporation occurs, which means some of the water molecules will become gas, even though it is not the boiling point of water yet. So, for the particles that become gas at a temperature when they should be staying as a liquid or solid, those kind of gas particles are called vapor. Vapor is a gas that exists at a temperature and pressure at which it ordinarily would be thought of as a liquid or solid. Okay, so the moisture in the air, those are called vapor. Well, when we were talking about the temperature impact on the rate of evaporation on the last slide, I talked a lot. So I'm going to summarize it here again for you. Okay, higher temperature, faster evaporation. A cooling effect is produced in the liquid when evaporation occurs. A gas that exists at a temperature and pressure at which it ordinarily would be thought of as a liquid or solid is called vapor. In the next episode, we're going to go into the details of evaporation. We're going to focus on the vapor. We're going to use water as example. We're going to focus on the water vapor. And we have a lot to learn about it. See you next time.